Dear ladies and gentlemen, I'm pleased to present to you today our research project start2park, determining, explaining and predicting cruising for parking. To introduce myself, my name is Sabine Scheel-Kopeinig. I am senior researcher at the Research Lab for Urban Transport at the Frankfurt University of Applied Sciences. We work with an interdisciplinary research team in the fields of traffic planning, economics, and data science. And in our research project, we are working together with two companies, Fluxguide from Vienna, which is an app developing company, and Blick from Berlin, who have experience with big mobility data and machine learning. Our project is funded by the German Federal Ministry of Transport and Digital Infrastructure, and our project started 1 year ago in July 2020, and it will end in June 2023. So what does cruising for parking mean? Let me give you some background information. Parking search or cruising for parking traffic is traffic that occurs because drivers are looking for a free parking spot that meets their expectations. For example, drivers are looking for a parking spot that is big enough or near enough to the destination point or not too expensive and so on. So cruising for parking causes external costs like traffic jams, emissions, time spending. Traffic planning policies, which should reduce cruising for parking traffic, require measures differentiated by urban district types and times of day. But cruising for parking has not been convincingly measured yet. Measured values so far vary greatly due to different geographical areas, times, and methods. So empirical values obtained were from 36 seconds for the mean parking search time in Amsterdam to values of 9 minutes on average and even more in other cities. Common methods to measure parking search time are exposed surveys and using GPS data. Both do not determine the start time of cruising for parking exactly, so the collected values may be biased. In case of service, drivers are asked after you found a parking spot. How long have you searched for finding this parking spot? In case of GPS data, assumptions have to be made as to when parking search starts. Does it start when you enter a radius of 200 or 400 meters around the destination point? Another aspect is that individual predictions of cruising time are not implemented in navigation devices yet. Therefore, the attractiveness of private car use compared to other means of transport appears higher than it actually is. Maybe riding a bike or using public transport would be better. Implementation of parking search time in navigation apps could reduce unnecessary parking search traffic, and this would be associated with reductions in emissions, traffic volume, and travel time. So what are our research objectives and how is our project setting? Well, since November 2020, we conduct pre-test drives to get a deeper understanding of the cruising for parking process. I will show you some results later on. We will collect cruising for parking traffic precisely, including the exact start point and data of influencing factors using an app, which is developed in our project. This app will be available in app stores from July this year on. Given this data in combination with existing real-time data like traffic data, weather data, and so on, we will determine an explanatory model and a prediction model. To give you some information about our start2park app. Our research project closes a research gap by precisely measuring parking search time based on collecting tracking data via app developed for this purpose. We will collect way and time points of trips ending with cruising for parking at many different geographical areas and times. In particular, we are able to determine precisely the starting time of cruising for parking. The driver clearly indicates when he starts looking for a parking spot. The start2park app is developed in collaboration with our practice partner Fluxguide from Vienna and will provide a state-of-the-art mobile interface that is fine-tuned for ease of use while driving. The application will be rolled out across platforms for both iOS and Android devices. We will also collect driver, vehicle, trip, and parking related data for our explanatory model. We will collect, for example, how well does the driver know the parking situation at the destination point, which vehicle class is driven, which purpose has the trip, which parking spot was found, on street or off street or maybe illegal. And the data collection period will be 1 year and at least 1,000 test drivers will be targeted. In approaching potential users, we are supported by a large German automobile club as well as several major German cities. So the explanatory model should help us to better understand factors influencing cruising for parking. Given that, we will be able to derive recommendations for traffic planners. Furthermore, we will determine average parking search times by district types and days of week, respectively time of day. We do so by extrapolating tracking data. In a prediction model, which will be based on machine learning, cruising for parking for individual trips will be predicted, and we will prepare the integration in navigation devices. So to give you some results of our pre-test drives, let me tell you that we conducted 196 pre-test drives in 2 German major cities since November last year. We collected tracking data and potential influencing factors, for example, the purpose of the trip and so on. Additionally, we asked drivers to give us an individual estimation of trip duration. We have also collected the expected trip duration via Google Maps. On the slide, you see parking search times in Frankfurt geographically visualized. And what you see are red and blue dots. The red dots show parking search time equals 0, and blue dots here over there are show parking search time greater than 0. And the larger the blue dot, the longer the parking search time is. Not surprisingly, we see the blue dots in downtown and near downtown areas. On average, we measured a mean parking search time of all pre-test drives from 1 minute and 17 seconds. And over those trips which had a positive parking search time, we measured on average a parking search time of 1 minute and 58 seconds. On average, drivers start about 100 meters from their destination point to cruise for parking. And in contrast, empirical studies assumed a radius of 200 and 400 meters using GPS trip data. On the slide, you see also the estimates for the trip duration in blue from the drivers. We see the estimates from Google Maps in orange, and we see the actual trip duration in green. And what we see here is that individuals overestimate trip duration by approximately 1 minute on average, while Google Maps underestimates a trip duration, about the same as parking search time is. Also interesting is that we see that parking search time correlates with the number of point of interests around a parking spot. Well, what are point of interests? That are geo objects that may be of interest to users of navigation systems, for example, shops, facilities, restaurants, or something like that. And what we see here is on the x-axis, the number of point of interest around the parking spot within a radius of 500 meters. So we see here 20 point of interest, 40, 60, and so on. And on the other axis, we see the parking search time in seconds. And parking search time significantly correlates with the number of point of interests around the parking spot. So if you are interested in this project and our coming up results, stay informed via our website start2park.com. I thank you very much for your attention. Ευχαριστώ πάρα πολύ, and I'm at your disposal for any questions now.